Hi there, and first of all, I'd like to thank you all for joining me, and it's a great privilege for me to be able to talk to you for the next 20 minutes or so. My name is Brian Odgers. I work for a company called IOT, which was founded by Allstate a few years ago. And we work with a wide range of companies on their telematics solutions. So if you were expecting a sales pitch here, you would be really, really disappointed. I'm not going to muse about how IOT is a mobility and data and analytics company, and I'm not going to ask rhetorical questions like imagine a world that has smarter, safer, and more efficient transportation systems. What I am going to do is tell you about IOT's IoT telematics solution and how we use that data to provide insights. The second part of this presentation is going to be around those insights, specifically about how transportation has been impacted during the COVID-19 outbreak. So straight away, I'm going to talk about the IoT solution. So when you look at your mobile phone, you probably think of making calls, some of your favorite messaging apps. Some of your favorite also apps that you use every day. When I look at a mobile phone, I think of the sensors in it, the accelerometers, the gyroscopes, even the GPS. And the mobile phone is core to our IoT solution. But we've also got other IoT devices. We've got a little in-car device that you plug directly into your car, and it reads off your ODB2 device, so that's your in-car computer. The flexibility of that doesn't only give us GPS data, speeding data, but it gives diagnostic data as well. So how good your fuel consumption is. And every time there is one of those little lights that come onto your dashboard, we get that event as well. So it adds a new dimension to the information that we can gain insights on. We also work directly with car manufacturers, and they send us their in-car data directly. So in this case, we are actually looking at the car as our IoT device. So it's okay, we've got all these IoT devices, a whole range of them, and they're streaming hundreds of millions of pieces of data to us a day. But we have to then think about how do we process and store that, and then how do we give insights on that information. And if you think about it, this is core to any IoT project. You have to be thinking about these things. What is the data that your IoT is capturing? How are you going to store and process that? And how do you get insights on it? And we do the store and processing through the power of our platform. Now, with this hyperbole, you're probably thinking to yourself, this guy is a platform guy. And I run the platform team here locally. So what you have here is our list of IoT devices, and they're pushing the data into our systems. But we originally had an on-premises Java Oracle solution. We decided to move to a cloud AWS solution. And we did this mostly because of flexibility. We had these large projections of increase in the amount of users, and we thought moving to the cloud was the best way of doing that. But it opened up a whole new range of technologies. So we look at Apache and Flink to bring this streaming data in. We look at NiFi and Kafka to push the data through our internal systems. We process our data using Go and Kotlin and Java. We use short-term storage using NoSQL databases like Cassandra. And then for our long-term storage, we can start looking at things like Hadoop and pushing it directly to the S3 buckets. But this was a massive challenge to us. We had to completely reskill and upskill our staff. And we created a really diverse team that had a wonderful range of experience and skills and expertise. And we successfully built this platform, and it allowed us to move from about 2 million users to 20 million users in a matter of days. But it's okay to think about it. Okay, we're getting all this data in, we're processing it into these lovely common format models, but what do we do with that data? And that's this last square. We hand it over to our data engineers and data scientists and allow them to gain insights from the data. So we think of a score of our users or our drivers, and that tells them how good or bad or indifferent a driver they are. We also give them insights into their behaviour. So do they speed? Do they hard brake? Do they hard corner? And we are hoping that information will lead to them being a better driver. We also do detection, and this is really important. If we can detect that people have been in accidents, we can inform the emergency services or even their friends and families. But the main insight I'm going to talk to you about now is the insights that we have done around the impact on transportation during COVID-19. But I really, really want to make clear at this point, without having the IoT devices streaming our data into our platform and the platform processing and storing that data, we would not have been able to give these insights. All three things go hand in hand. Can you read through this disclosure while I keep on talking? This is going to be a Realmousy Bet, so I really want you to prepare yourself. Get back to your GCSEs and that sort of level of maths. We took a representative sample of our data and we ensured that it had all our different customer segments, both insurance and non-insurance. And we also made sure that it had the whole range of IoT devices that we have previously discussed. We have about 23 million active users at any one time, and we used a representative sample of about 3 million users. In this time period of the beginning of February to the end of the middle of March or May, that this is around, that gives us about 500 million trips and 5 billion miles of data as our sample. So it is a big, big sample. So here is the Realmousy Bet. So as I mentioned, we started on the 1st of February, and on the 2nd of February, we normalized the data to a 100. And that is to make the maths easier for you. So instead of these y-axis being these huge numbers in the millions, they're more or less percentages. Then we created this dashed line that you would see on some of the graphs, and that is our counterfactual. We extrapolated through our 2019 data and 2020 data to what we would have expected the levels to be if COVID hadn't kicked in. And as you see, all these increase slightly, and that's the seasonal differentiation. That's the longer summer nights and people actually going out and doing that a bit more driving. The blue line is what we observed on the dip due to COVID, and this orange lines are the difference between those. So in reality, what we're talking about here is the percentage difference. So we first of all looked at what we call active connections, and that's really people getting into their car and driving. And we see a massive drop of nearly 40%. So 40% of people are being mindful and not getting into their cars and driving. Of the people who are driving, we looked a wee bit more into their stats. We noticed that the number of trips for them plummeted to sort of in around 20-25% less. And what that means is that people are being more mindful of actually getting into their cars and driving. To take that one step further, those active drivers, those people who are driving, we looked at the miles that they were actually doing. And again, it had that big drop of in around 25%. So if you take into those three considerations, the fact that a large amount of people are deciding not to drive, and even the people who are driving are doing less trips and less miles, you have this quite dramatic decrease in driving of over 50%. And if you think about it, if you anecdotally could see this as you looked out your window, you could have seen that there was far less traffic on the road. But you can also see this happening as well, that you're actually seeing more people on the road. There's still a massive decrease, but there's more people out there driving as people become more normalised. But what we can all say that all drivers are not the same. We see about 20% of drivers are increasing their number of trips and 29% are increasing the distance they travel. And we believe this is partly due to the change in our economic environment. More of us are asking for delivery service. Even my local butcher delivered during the peak of the COVID crisis. And if you think about it, every time you get a delivery means somebody is falling into this group. They're having to make that extra trips and do that extra miles travelled. This is probably the most tricky graph that I've ever tried to explain. I'm going to do my best. What we've seen is that there was a real difference in the driving patterns of people in rural, low-density population areas compared to metropolitan urban areas. And we can see in this top line, this really light purple line, that's low population densities. Those are your rural environments. And we can actually see down here that in some cases, the amount of journeys are increasing and the number of miles is increasing. But as we go into these sort of more suburban areas and urban areas and into metropolitan areas here in the dark purple, you're getting this gradual increase of the impact on driving up until you're talking about your 40, 50, 60s, even into your 80% reduction in journeys in your high population metropolitan areas. And if you think about that, that is kind of reasonable. For these low population areas as our agricultural communities, these are the people who still have to go out and farm the land and care for our animals. And that was also a big push to make sure that those produce were still reaching the shops and onto our plates. So they had no chance of changing their driving habits. But here in these more cosmopolitan areas, people started to work from home. They started to be more mindful about doing trips to their friends and families. And they maybe walked to the corner shop instead of going to their local supermarket. And that's where you see this drop. But we actually see this in local areas as well. So if you look at inner city Belfast, they would have a high decrease, but as you went into suburbia, it would be lower, and out into those rural farming communities, there would be little to no impact. This graph always makes me smile, and it gives me back faith in humanity. This driving data is around the US, and there was on this line shows when the federal government came in and said, well, we're going to have a state of emergency, but they gave the legislation to the states to actually define the lockdown measures. And the first one called in was California, which is here, and the blue line is the states that have lockdown measures in place. The black line, on the other hand, is the 7 states that had no legislation to lock down, but we can still see this massive decrease in driving. Even when people were not told that they needed to stop driving, they still did. They still were mindful, and they came and made sure that they weren't driving. And this sort of self-preservation mode kicked in. The other part of here that interests me is this little part here, right at the top. And even before federal government came in and said that there was a state of emergency, people had already started to change their habits. As I mentioned at the beginning, we do a thing called a driving score where we score drivers of how well we're doing, and it's a range of 0 to 100, where these sorts of 80 to 100s are excellent drivers. You're brilliant. 0 to 20, you're rubbish. And what you get is a classic Bell distribution of those driving scores. But you see here the black and blue lines, which represent pre and post-COVID, the distribution are exactly the same. So the same distribution of drivers are still driving during the COVID crisis. So it's not like all the bad drivers get out and start driving and all the good drivers lock themselves in their house. It's still this natural bell curve. These ones too are easy. We have this idea of an average driver, and we have a couple of measures around it, but our different measures, and I'm showing two here, showed a slight drop in the score of our average driver. So our average driver was becoming a slightly worse driver. And when we looked in that, the main part of that was speeding. And we can see here, this is just looking at driving over all the speed limits. And as the blue graph moves to the left and up, we can see that the speeding that basically indicates the speeding is getting worse, so it's getting higher and more often. And it is a marked difference here, but the big one is in this graph, and this is high-speed journeys. So these are our big dual carriageways and our motorways. And this is a huge gap and a huge move to the left and up. And if you think about it, it is kind of reasonable, and that previously these big motorways and dual carriageways had any number of traffic on it, and it was people were just going at a certain rate. But now they're empty. People are flying along them. But this speed change in speeding behaviours impacts your driving score, and it makes our average driver worse. So just to do some conclusions here and recap on some of the insights that we got. So we first talked about how driving and the number of miles people are doing have massively decreased. And in around 50%, and we can anecdotally see that by looking out our windows. We said that all drivers aren't the same. There's ones that are travelling more and doing more miles and more trips, and we believe that's impacted from the change in our business models where there's more delivery services. We looked at the impact of a population density where those rural agriculture communities have not been impacted at all by COVID. They're still driving exactly the same, if not a bit more. But as we move into suburban, urban and cosmopolitan areas, the impact has been massive. We got a warm feeling about our faith in humanity where people have still got self-preservation, and even though governments weren't telling them to lock down, they still were mindful about the trips they were doing and the journeys they were taking. And finally, people are getting worse drivers on average during the COVID crisis, and that's to do with speed, and especially speed on our motorways and dual carriageways. So the last part of this presentation, I want to go back to the point of this talk, and to look at IoT technologies and solutions. And if you're going to take one thing away from this, I think these 3 points are really important. For any IoT solution, you need to be thinking about these 3 things. What are your IoT devices and what data they're producing? How you're going to store and process that. So looking at both your long-term and short-term storage, and also maybe processing that data from your different data sources into some sort of common model. And then finally, the insights. So it's no sense in having all this wonderful data if you aren't actually gaining insights to give your customers that added value. Now, I'd actually say you'd think about it in this order if you were an IoT device manufacturer, but at RD we actually think about it the other way around. We start with a business statement or a business problem, and we maybe say a statement like, improving transportation starts with understanding how people move from A to B. And we think, well, if we want to solve that problem and understand that more, what insights do we need to gain? And from those insights, we say, well, what data do we need to store and how do we need to process that data? And finally, we think about, well, what do our devices need to be passing to us? So you can think about these things are really important, and you can think about them in the two different ways. From a device perspective, when you're thinking about what your data you're producing and the insights you're gaining, or their business problem starting with the insights and moving to the IoT capture. So again, I just would love to thank you for letting me spend some time with you today. And if you have any questions, please do not hesitate to contact me.